For more than 2 decades, the mainstream view was simple. Supersonic passenger travel was over. Concorde was retired in 2003. In 2022, when Rolls-Royce, GE, and Pratt & Whitney all refused to build a new supersonic engine, many experts saw that as the final blow. No startup had ever built its own jet engine for this job. The message from the aerospace world was blunt. If the biggest engine makers said no, the dream was dead. This video will show you why this method disappeared and how to bring it back step by step. That is the tension at the center of this story. One side says the age of fast civilian flight ended for good when the old system became too costly and too hard to justify. The other side says the old system failed because the machine was wrong, not because the mission was impossible. And in the United States, one startup has been trying to prove exactly that. The wider transport world has been focused somewhere else. Much of the attention in recent years has gone to electric and autonomous vehicles, especially electric vertical takeoff and landing aircraft, often called eVTOLs. Companies like Joby Aviation, Archer Aviation, and Boeing have pushed that part of aviation hard. According to Morgan Stanley in 2020, the global urban air mobility market could reach about $1.5 trillion by 2040. Deloitte said in 2021 that the global eVTOL market is expected to grow by 30% each year between 2021 and 2030. The United States Department of Transportation announced nearly $100 million in 2021 for advanced air mobility research. The FAA set a framework for eVTOL testing and certification in 2021. Joby received its Part 135 certificate in 2022. Archer made its first full flight test in 2023. That was the mainstream future. Short urban hops, electric aircraft, flying taxis above traffic. Even public interest was there, though mixed with fear. The International Air Transport Association said in its 2022 survey that 68% of respondents were interested in flying taxis, but 57% had safety concerns. The debate was about city noise, traffic in the sky, and how to regulate a new kind of machine over crowded streets. Boom Supersonic chose a very different target. Not 10-mile city trips, not batteries, not urban hops. It went after the hardest prize in civil aviation, the return of supersonic passenger travel. That decision went against the consensus. It also went against the money flow, the policy focus, and the mood of the industry. In a market chasing electric air taxis and slow, careful steps through certification, Boom was trying to bring back something the public mostly remembered as glorious, loud, expensive, and gone. Then came the moment that changed the argument. On January 28, 2025, Boom's XB-1 broke the sound barrier 3 times over the Mojave Desert. That mattered for one obvious reason. It went supersonic. It mattered for a second reason that may be even bigger. No audible boom reached the ground. That flight was presented as proof that Mach cutoff physics works. Mach cutoff is not magic. It is a flight condition where the shock wave bends upward instead of striking the ground in a way people can hear as a sonic boom. Put simply, the aircraft goes fast enough and high enough under the right conditions that the boom does not land where people are standing. For decades, overland supersonic flight in the United States was blocked by the noise problem. XB-1's flights over the Mojave were a direct shot at that barrier. The phrase, "first civil supersonic jet ever made in America," gave those flights extra force, not military, civil. Built to prove a future passenger aircraft could fly faster than sound and address the exact problem that helped kill the old era. That does not mean the full airliner is already flying. It is not. The aircraft in development is called Overture. XB-1 is the demonstrator, the proof machine, the aircraft built to test the ideas in the air. That difference matters. In aerospace, a mock-up can look perfect on the ground and still fail in the sky. A demonstrator has to face reality, and reality in this case meant physics, heat, structure, control, and noise. If Boom had only made a sleek prototype, the industry could shrug. If it had only shown computer images, the industry could ignore it. Breaking the sound barrier 3 times changed that. It turned a theory into flight data. Now look at the aircraft Boom wants to build from that proof. Overture is designed to cruise at Mach 1.7 at 60,000 feet. It is planned to carry between 64 and 80 passengers. Boom says it could fly from New York to London in about 3.5 hours. Those numbers explain the appeal better than any slogan. The route is familiar. The time cut is easy to understand. The altitude and speed show the aircraft is not just a little faster than today's airliners. It is operating in a different band of travel. The engine is where the story gets even more serious. After the major engine makers refused to build one in 2022, Boom moved toward its own in-house engine, called Symphony. That decision challenged one of the strongest beliefs in aerospace. The belief was simple. A startup can design an aircraft concept, a startup can build a small demonstrator, but a startup does not build its own supersonic passenger jet engine. Symphony is described as a 35,000-pound thrust turbofan with no afterburner. It is designed to run on 100% sustainable aviation fuel. Core testing is underway in 2026. Each of those points matters. 35,000 pounds of thrust places the engine in a serious class for a passenger jet. No afterburner matters because afterburners are fuel-hungry and noisy. If you want a machine that fits commercial service, dropping the afterburner is a major design choice. The sustainable aviation fuel point matters because any return of supersonic travel will face questions about emissions from day one. Boom is not just trying to go fast. It is trying to show that fast does not have to mean repeating the old model exactly as it was. This is where the common belief needs a hard challenge. The usual story says supersonic passenger travel died because people no longer wanted it. The evidence in this story points somewhere else. The better reading is that the old system died because it was too expensive, too loud, and too limited by the technology and rules of its time. If a new aircraft can cut the noise problem, use a different engine approach, and find buyers before service even begins, then the demand question looks very different. That does not prove success. It proves the old obituary was too simple. The factory story is another reason this project moved beyond hype. In Greensboro, North Carolina, Boom built the Overture Superfactory. The site covers 179,000 square feet. It was built in under 17 months. The plan is to scale toward 66 jets per year. That is not how a company behaves if it is only trying to attract attention with a concept image. A superfactory is a statement about production, supply chains, workers, tooling, and rate. Aerospace history is full of companies that could build one impressive aircraft and never build the second one on schedule. A factory aimed at 66 jets a year means the real challenge is being treated as industrial, not just experimental. And there is another hard data point behind it. Boom says it has an order book of 130 aircraft from United American and Japan Airlines. That order book does not mean Overture is in service. It does mean major airlines are willing to reserve places in line for an aircraft that does not yet carry passengers. For the market, that is a signal. For suppliers, it is a signal. For rivals, it is a signal. Airlines are not just buying speed. They are buying time, route appeal, and premium demand. The location matters too. Greensboro is already tied to aviation manufacturing. That gives the project a home in a place that understands how aircraft get built, inspected, and moved through production. In stories like this, geography can shape the outcome almost as much as engineering. The policy wall began to shift in 2025. In June 2025, an executive order ended America's 52-year ban on overland supersonic flight. That is one of the biggest developments in this entire story. For half a century, the rule itself stood as a warning to any company dreaming about faster domestic travel. Even if the aircraft worked, the market would be boxed in. Ocean routes only. Land crossings restricted. A machine built for speed would be trapped by law. The end of that ban does not erase every rule. It does not guarantee open skies for any aircraft that claims to be quiet. It does change the direction of travel. The United States is no longer treating overland supersonic flight as forbidden by default for the next 50 years. It is now a question of proving the aircraft can meet the noise challenge. That shift links directly back to XB-1's flights over the Mojave. The flight test and the policy move point at the same target. Remove the boom from the ground and you reopen the map. NASA's X-59 adds even more weight to that push. Its first flight is set for October 2025. That matters because the quiet supersonic case is no longer being argued by one private company alone. NASA is also working on the same broad problem. Different aircraft, different role, same central barrier. Can you fly faster than sound without punishing people on the ground with the boom? When a startup demonstrator, a future airliner program, a federal rule change, and a NASA quiet supersonic aircraft all line up around the same question in the same year, the field no longer looks dead. It looks active. That is the bigger meaning of this American transport vehicle. It is not just a fast jet in development. It is a test of whether the country can reopen a part of aviation it once abandoned. The contrast with the rest of new transport makes this even sharper. eVTOL aircraft promise to change short urban trips. Morgan Stanley's $1.5 trillion estimate by 2040 shows how large that bet is. Deloitte's 30% yearly growth forecast from 2021 to 2030 shows how quickly that sector hopes to expand. Public funding, FAA frameworks, and company milestones all support that path. But eVTOLs are trying to solve traffic inside cities. Supersonic passenger travel is trying to solve distance itself. One asks how to move across town faster. The other asks what happens when a coast-to-coast trip can drop below 4 hours. That is the near future hinted at by the rule change in June 2025. And by the quiet supersonic work now underway. If overland supersonic flight becomes practical, the map of the United States starts to shrink in real time. Business schedules change. Same-day trips across the country feel different. Airline competition changes. Airport networks change. A 4-hour crossing is not just a speed gain. It changes what counts as near. There are still real obstacles. The aircraft is in development. The engine is still heading through testing, with core testing underway in 2026. Certification is still ahead. Production scaling is still ahead. Quiet flight has to be proven again and again, not once. A demonstrator breaking the sound barrier 3 times is a strong start. It is not the full end of the job, but that is exactly why this story matters now. The consensus was not cautious. It was final. The old view said the idea was finished. Concorde was gone. The engine makers said no. The rulebook blocked overland use. The startup should have folded its wings and joined the rest of the industry in safer markets. Instead, Boom answered each of those walls with a different kind of proof. Against the claim that American civil supersonic flight was dead, XB-1 flew. Against the claim that sonic boom would always lock fast flight out of domestic travel, the Mojave tests showed no audible boom reached the ground. Against the claim that no startup could carry the engine problem after the big manufacturers refused, Boom moved ahead with Symphony, a 35,000-pound thrust turbofan with no afterburner, designed for 100% sustainable aviation fuel. Against the claim that this was just a render and a dream, the company put up a 179,000-square-foot factory in Greensboro in under 17 months, and pointed it toward 66 jets a year. Against the claim that airlines were not interested, it built an order book of 130 aircraft from United, American, and Japan Airlines. And against a legal wall that had stood for 52 years, the United States changed course in June 2025. That does not mean the race is won. It means the impossible case is broken. For aviation fans, that is the real shift. Not that a supersonic airliner is already carrying passengers. Not that every engineering problem has vanished. The shift is that the argument has moved from never again to show us the data. That is a huge change. Aviation moves in long cycles. Ideas fail, sit dormant, then return when materials, engines, rules, and market demand finally line up. Supersonic passenger travel may be entering that kind of return, not as a museum memory, not as a tribute flight, as a live industrial program with a demonstrator, an engine plan, a factory, airline backing, and a regulatory door that just opened. For years, the future of transport in America seemed headed toward batteries, autonomy, and short-range flight above city streets. That future is still coming. The research from Morgan Stanley, Deloitte, the FAA, and the Department of Transportation all points that way. But another future is now back on the table, one built around altitude, Mach number, thrust, and time saved over long distances. If Boom can turn XB-1's proof into Overture's service, the result will not just be a new airplane. It will be the return of a speed class that much of the world had already buried. And if that happens, the machine that changes travel forever may not be the quiet electric taxi rising above downtown traffic. It may be the American supersonic jet climbing to 60,000 feet, accelerating to Mach 1.7, and making the country feel smaller than it has in generations.